Hello everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 2 for May-June 2021, and the code is 9709/61. So let's move on to question number 1. Question number 1. Accidents at two factories occur randomly and independently. On average, the numbers of accidents per month are 3.1 at factory A and 1.7 at factory B. Now find the probability that total number of accidents in these two factories during a 2-month period is more than 3. Okay, so here the 3.1 means per month, right, for the factory A. And then now from here, the 1.7 is for factory B, right? And now we are interested to get the total number of accidents, right? So now I will find the total number of accidents per month first. Okay, so that means now here 3.1 plus 1.7, that is going to be 4.8. This is per month. But then now you are requested to calculate the probability of the total accidents during 2 months period. That means now here I will write my lambda is basically 2 times 4.8 because this 4.8 is per month. Okay, so then this is going to be 6.9. That means now here I will write T is Poisson distributed because you are given the interval per month per 2 months. This is Poisson distributed with the lambda 9.6. So when you write this, that means this 9.6 or this T is the total number of accidents in 2 months, right? So now, and you are asked to calculate the probability that's more than 3. So P T more than 3. Right? So now for the Poisson distribution, X is Poisson distributed with mean lambda. Probability of X equals to X is basically E minus lambda. You can write lambda or mu, right? So minus lambda degree X over X factorial. Then the X will be from 0, 1, 2 until infinity. So now this is greater than 3. Greater than 3 is basically 4, 5, 6 and onwards. So we do not know when to stop. Therefore, I will use the complementation rule. That is, okay, look at here. You need to calculate 3, 4, 5 and onwards. So it means that you are counting 4, 5 and onwards. So I will say total probabilities 1 minus the previous probabilities. That will be the T greater than 3 probability. Okay, that means now here it will be 1 minus Px equals to 0 until 3. Okay, then just use the formula. But when you look at the formula, this is in common because exponential minus lambda is a fixed number. Right? So I will factorize exponential minus 9.6. Then now where x equals to 0 means that to get lambda with degree 0, that is 1. 0 factorial over here is also 1. So first term is always 1 plus 9.6 degree 1 over 1 factorial. No need to write that. Then plus 9.6 degree 2 over 2 factorial plus 9.6 degree 3 over 3 factorial. Okay, then from here, when you calculate the numbers, the values of the brackets and together with the exponential negative 9.6, you will be getting 0.01383. Okay, then now when you calculate this value, that will be 0.986, correct to 3 significant figures. That is the solution for question number 1. Okay, question number 2, the time in minutes taken by students to complete a test has the distribution. This is a normal distribution. A, find the probability that the mean time taken to complete a test by a random sample of 40 students is less than 123 minutes. Okay, this is normally distribution. Okay, normal distribution. But then now it's mentioned here, mean time. Alright, so therefore my x bar will be normally distributed. the mean remains, but then the variance no more 36. It will be 36 divided by 40 students, because now you are counting mean time. Okay, so now the probability P, mean time less than 123. So now look at the formula here. X is normally distributed, mean mu, variance sigma squared. Okay, so the standardized normal random variable is x minus mu over sigma. But if let's say now it is x bar, normally distributed with mean mu, variance sigma squared over n. So your z, it will be same concept, x minus mu. So now x bar minus mu. Okay, the sigma here basically is the square root of the variance. So here becomes square root of sigma squared over n. Alright, so this is the formula that we are using now. That means this is going to be P z less than 123 minus 125 over square root of 36 over 40. Alright. So when you calculate this value, this is going to be P z less than negative 2.108. So now here, I will sketch a graph. The middle value is 0 because it's a symmetrical graph. Less than negative 2.108. This is the value. And region is towards the left side. But then you should understand that for the normal distribution graph, okay, based on the table in the formula list, you need to flip this over, or you need to reflect it because it is symmetrical at origin, at the 0. So now I will write the orange region is basically same as the blue region. So when you flip it to the positive side, I will be getting 2.108 for this orange line. Okay, so which means instead of counting P z less than negative 2.108, you are counting probability of probability of z more than 2.108, right? So to count this probability from the table, you are just given the probability less than the positive value. Therefore, it will be 1 because the total probability is 1. 1 minus Pz less than 2.108. So here I will write this is same as Pz more than 2.108, 108. And this is counted using 1 minus Pz less than 2.108. So now just read the probability from the table. You will be getting 0.9824. And then when you calculate this value, that is going to be 0.0176, which is 3 significant figures. So that's the solution for A. Now B, explain whether it was necessary to use central limit theorem in this solution. So actually when you refer back to the question already given normal distribution. That means we do not apply. So central limit theorem is used when the distribution of the population is not given. Okay, so no, because the population is normally distributed. Okay, so this is the reason. Question 3. The graph of probability density function of a random variable x is symmetrical as about the line x equals to 4. Okay, now given P, the probability of x less than 5 is 20 over 27. Find probability of x between 3 and 5. Okay, let's say for example, I just simply sketch. Right, let's say symmetrical. Symmetrical about the line x equals to 4. That means here is 4. So when it is symmetrical means that all these properties will be 0.5 because we know that total probability is 1. Alright, so now given that Px less than 5 is 20 over 27, that means now Here is 5. This is 20 over 27. So I can find out what is this, right? So from here, I will know that my P, okay, so probably you can just write, since PDF, probability density function, PDF of x is symmetrical about x equals to 4, that means Px less than 4, it will be 0.5. Okay, that's the meaning of symmetrical. So that means now Px between 4 and 5, okay, as shown on the diagram here, the orange color, it will be 20 over 27 minus 0.5. Okay, then you will be getting 13 over 54. So the 0.5, you can say this is half as well. So probably I will just write half. Now, I found that the orange color is 13 over 54. And it's mentioned that symmetrical about x equals to 4. Now, to get x, the probability of x between 3 and 5, that means here, this is your 3. So obviously, the 3 to 4 is the same as 4 to 5. Okay, so then from here, probability of 3 to 4 is same as probability of 4 to 5, which is 13 over 54. Hence, the probability of x between 3 to 5, that is 13 over 54, you can say times 2 or just plus together. Okay, so probably I guess times 2 because you are adding both. So therefore, that is 13 over 27. So that's the solution of this question. Okay, question number 4. 100 randomly chosen adults each throw a ball once. The length L meters of each throw is recorded. And you are given all these summaries. Calculate 94% confidence interval for population mean length of throws by adults. So now, because of the population mean length, I need to calculate L bar. L bar means it's the mean of the sample mean. Okay, sample mean of the lengths. That means that will be summation L over N. Then it will be 3820 over 100. I will be getting 38.20. Okay, then now for the variance, sample variance. Okay, so it will be, sorry, this one shouldn't have bar. So it will be SL squared. So the formula is basically 1 over N minus 1 summation L squared minus square of summation L, then over N. Then from here, you just replace the values. It will be 1 over 49. 1 over 99 because your N is 100. So 1 over 99. Summation L squared is given. This value, 182,200 minus square of the summation L, 3820 squared over 100. Then this is going to be 12092 over 31. So I leave it in fraction first. Okay, now 94% confidence interval for mu. Okay, population mean. So for mu, that is going to be L bar plus minus, okay, Z alpha over 2. That means it's 0.03. Then square root of SL squared over N. This is the formula. Now here, you sketch a graph. Because we know that it's 94%, right? And the T is large, right? Basically the T is large. Not T, the N is large, which is 100. Therefore, by using central limit theorem, we will be using the normal distribution to solve this question. So here, middle is 0, okay? And now here is 94% confidence interval. That means now when we label the region in between, okay, two lines, in between these two lines, it will be 0.94. So when here is 0.94, remember, we are using the normal table. That means another two parts here will be 0.06. The total of these two parts will be 0.06. So that the total is 1. So 0.06 divided by 2, that is 0.03. That's why I wrote here 0.03. Okay, then now here, from the normal table, we are using the total regions towards the left side. Right? Therefore, this is 0.97. So when you add up these two values, 0.97, and now you read the table. When it is 0.97, the probability you are getting 2.10, sorry, you are getting 1.881. So that means the other line will be negative 1.881. Okay, so now L bar already counted just now, 38.20. So I will just write 38.2. Plus minus, the critical value will be 1.881. Then square root of this value, this is basically 31. So 12092 over 31, that over 100. Okay, so now, sorry, it is not 31, that is 33. Okay, I overlooked the value. It should be 33. Okay, so now here I will calculate the second value first. 1.881 times the square root. So that is going to be 3.6006. Then now we calculate the lower limits using minus first. You will get 34.5994, and the other one is just the addition of two values. You will be getting 41.8006. And our final answer round up to 3 significant figures, right? So that is going to be for 34.6, and the upper limit is 41.8. So that's the confidence interval for the mu. Okay, question 5a. On average, 1 in 75,000 adults has a certain genetic disorder. A. Use a suitable approximating distribution to find the probability that in a random sample of 10,000 people, at least one has the genetic disorder. Okay, so now since we are considering 10,000 people, okay, that means initially this is binomial distributed, right? So X is binomial because it's people, right? So the N is 10,000, and then the P is supposed to be 1 over 75,000. Okay, but you are given the hint using suitable approximating distribution. Now you have to check whether you use normal approximation or Poisson distribution. So for your information, X is binomial with N and P. Alright, so now from here I will say I need to calculate my NP first. Alright, so my N is 10,000, and then my P is 1 over 75,000. So now my NP is 10,000 times 1 over 75,000. This is going to be 2 over 15. Okay, so from here I know that N is greater than 50. Okay, NP is less than 5. Therefore, the binomial distributed will be approximate to Poisson. Okay, so my X is binomial distributed 10,000 1 over 75,000. For the P, it will be Poisson distributed because of NP less than 5. Then the lambda is 2 over 15. That is our mean NP. And now given that at least 1, so P, initially you are counting X at least 1. Okay, but then when you look at the approximating distribution here, this binomial is discrete. Okay, this Poisson is also discrete. So it means that they are same category of variable, both also discrete. So we do not need to use the continuity correction factor. Alright, so you just direct change to W greater equals to 1. So now, for the Poisson distribution, X is Poisson distribution, lambda, okay, or mu, Px equals to X, that is going to be E minus lambda X over X factorial. Okay, then again, the X start from 1, 2, 3, then continue. So now, greater equals to 1 means that 1 onwards. So 1 onwards, we do not know when to stop. Therefore, we use total properties 1 minus 0. Minus when x equals to 0. So this is going to be 1 minus Pw equals to 0. Okay, when Pw equals to 0 means that just consider the exponential. So it will be e power negative 2 over 15. And then this is going to be 0.125. The value correct to 3 significant figures. Alright, so done for this question. Now B, in a random sample of n people, where n is large, the probability that no one has the genetic disorder is more than 0.9. N people now. Find the largest possible value of n. Okay, so when you refer to the previous question, we found this 2 over 15 by using n times p. Okay, so now n is unknown. Alright, so we only have the p. So that means now my new mean, okay, it will be 1 over 75,000 times n. Alright, so now I will just write my W is Poisson distributed with 1 over 75,000 times n. That is my lambda. And now mention no one. So no one means W equals to 0 and is greater than 0.9. That is the given information in the question. So when Pw equals to 0, refer back to previous. When 0, you will just take E minus lambda. Okay, so now I will get E minus this value. This is my lambda. So it will be n over 75,000. Okay, then greater than 0.9. Then now here, to solve this, what we need to do is to eliminate the E. So to eliminate the E, you need to take ln both sides. Because we have this formula, ln EA equals to A. So now I take ln both sides. So ln E negative n over 75,000 is greater than ln 0.9. Okay, so now ln E for the left side, it will be the power of the E. Okay, now here, where I need to find the n, this negative 1 over 75,000 will be moved to the other side. So it means that when you move the negative value to the other side, we need to change the inequality symbol. So that means now n less than. Right? So when I move, it's basically times negative 75,000 ln 0.9. Then now when you calculate this value, that is going to be 7902.04. So it means that your n is less than this value. Therefore, the question asking for largest possible n. And now we know that n is per number of people. So when number of people, it cannot be in decimal. So your n less than this value, that means your largest n, it will be 7902. Okay, so that is the solution of this question. Okay, now question number 6. The probability density function f of a random variable x is given. Your fx is k times 6x minus x squared, where the x is defined from 0 to 6, and the fx is 0 when otherwise, means that for other x values, it will be undefined. Now, where k is a constant, state the value of ex and show this variance x. Okay, so now from here I will say my fx. I will rewrite my fx first. It will be k of, okay, I rearrange, minus x squared plus 6x instead of 6x minus x squared. Now from here I will have to get the symmetrical line. That means I have to find out what is the maximum point, okay, by using completing the square, because I need to state the ex. The ex is the expected x, which is also the symmetrical line, right? So then from here I need to factorize a negative from the two terms, and then I complete the square. So when I complete the square, I will get negative of, rewrite these two terms, and then always plus bracket squared minus bracket squared. Okay, so the term inside the bracket is basically the half of the coefficient of x. This is minus 6, so therefore I will write minus 6 over 2. Okay, then here it will be k of negative. Then, okay, this negative I can just combine with the k. It will be easier. Then I will be getting, okay, now when you have these three terms, first three terms, these first three terms can be combined by referring to first and last and the third term. So here you will be getting x sorry x minus 6 over 2 is minus 3. Then you square it, and minus, this is minus 3, so you square it, it becomes minus 9. Okay, so from here when I just do expansion, I will be getting negative k bracket x minus 3 squared, so plus 9k. Okay, this is the completed square form. Now from here I know that when you sketch a graph, okay, your minimum point is with coordinates 3 and 9k. Okay, because you let x minus 3 be 0. Therefore it's like this. Not minimum, maximum, because this is negative. When you do expansion, it will get negative x squared. So it will be like this. That means these points will have coordinates of 3 and 9k. Okay, so when it is 3 and 9k, obviously it is symmetrical at 3. X equals to 3. Okay, therefore the ex is the 3. Okay, because the ex is the expected value, the mean. So here you just write fx is symmetrical at x equals to 3. So hence ex equals to 3. Okay, so that's why state the ex. Now show variance x. So variance x, we need to use formula. This is basically ex squared minus square of ex. So here to get the ex squared, we need to do integration, but we need to find out the k first. So now integrate fx dx equals to 1. Okay, that is the total probabilities, and 0 to 6. So now since your fx is k times these two terms, so the k can be taken out first. I can factorize the k before I integrate. So k integrate 0 to 6, and then minus 6x minus x squared dx equals to 1. And now to integrate, you will get k integrate 6x, it will be 6x squared over 2. Then the x squared becomes x cubed over 3. Limits 0 to 6, then equals to 1. And then now here you will just write this is 3. Okay, then replace the values. So here is going to be 3 6 squared minus 6 cubed over 3. Then where x is 0, everything is 0, that equals to 1. So from here you will be getting 36k equals to 1. Therefore your k is 1 over 36. Alright, so now with this k we can calculate the ex squared. So now my fx, it will be 1 over 36 6x minus x squared, where the x defined from 0 to 6. Okay, so now we need to calculate the ex squared now. Ex squared is basically integrate from 0 to 6 x squared fx. This is the definition. So it means that now I will take out 1 over 36. And then I integrate from 0 to 6 x squared multiplied to 6x minus x squared. So when you do multiplication, before we integrate, you will be getting 6x degree 3. So 6x cubed minus x degree 4. And now for the integration, we just add 1 degree. That is going to be 6x degree 4 over 4 minus x degree 5 over 5, and then limits from 0 to 6. Now replace the values. So you will get 1 over 36. 6 over 4 is basically 3 over 2. So 3 over 2, 6 degree 4 minus 1 over 5 times 6 degree 5, and then minus 0. Okay, when x is 0, everything is 0. Then this is going to be 54 over 5. Now, after you have found this, variance x is basically ex squared minus square of the mean. So ex squared already found 54 over 5, and then the ex already solved just now, which is 3. So that means here it's going to be 3 squared. Then you will be getting the answer of 9 over 5. So that's all for this solution. Okay, next question number 7. The masses in kilograms of large and small sacks of flour have these two distributions respectively. So it means this is for large and the next one is for small. Now, A, some sacks are loaded onto a boat. The maximum load of flour that the boat can carry safely is 340 kilograms. Find the probability that the boat can carry safely 3 randomly large sacks of flour and 6 randomly chosen small sacks of flour. Okay, so basically for the large one, I used L. Large is normally distributed with mean 55, variance 3 squared. And then for the small one, which is S, it is normally distributed with mean 27, the variance 2.5 squared. Okay, now I need to find out the total 3 large and 6 small. So 3 large plus, okay, probably here I will just write expected value of 3 large, this is the mean, plus 6 small. Now use a formula EAX plus BY, this is AEX plus BEY. Okay, so then you factorize the 3, take out the 3, EL plus 6 ES. So this is the E, which is the mean. This is the E, ES, and EL. Okay, so expected value is basically the mean. So that means this is 3 times 55 plus 6 times 27. And then you will be getting 327. Now for the variance, 3L plus 6S, we have two formulas over here. So variance AX plus BY. Okay, we have A variance X plus B variance Y. This is for multiplication. For addition. That means the A is you are adding X for A times. So this is for addition. Another one is you square the coefficients. Okay, when you square, means that this is for multiplication. Now this multiplication means that probably is 3 times of that. So means that probably the A is a price for the X, right? So you have to mind price per kilogram. So probably the X is how many kilograms. So that means that is the total price. So then you use multiplication. But then in this case, this is 3 randomly chosen large sacks of flour and 6 randomly chosen small sacks of flour. That means we are using addition. It's like you are adding the 3 sacks of flour and also 6 small sacks of flour. Okay, so we are using the addition formula to solve this question. So then from here, I will just write this is basically 3 variance large plus 6 variance small. Then just replace the values. You will get 3 times 3 squared plus 6 times 2.5 squared. And this is going to be 64.5. So now, the question says, right, safely, can carry safely. Carry safely means that maximum is 340. Right? So it means that now, I will just write 3L plus 6S is basically normally distributed. The mean is 372, 327, and the variance is 64.5. And the boat can be carrying up to 340 kilograms. So it means that here should be less than. You can write less or equals to or just less than because it is normally distributed, which is a continuous random variable. So equal or not equal is not important. So from here, since it is normally distributed, then we need to standardize it. So when I standardize, it will be 340 minus 327 over square root of 64.5. Then from here, this is going to be PZ less than 1.619. So when 1.619, when you refer to the graph, is basically the region available in the table, which is here. Okay, so you can just direct read the region from the table. You will be getting 0.9472. And now you round up to 3 significant figures. That is going to be 0.947. Alright, so done for this solution. B. Find the probability that the mass of the randomly chosen large set of flour is greater than total mass of 2 chosen small sacks of flour. Okay, that means now you need to count P, 1 large is greater than 2 small. So again here, I need to write this is P large minus 2S greater than 0. So now I need to calculate my EL minus 2S, that is EL expected value L minus 2 expected value S. So then just calculate using the previous information 55 and 27 for EL and ES. So this is going to be 1. Okay, and for the variance L minus 2S, so again this 2S means total mass. Okay, total mass means no need to square the 2. But then when it is variance of minus, so here variance of AX minus BY, when this is addition, okay, or addition, I would say addition, it will be A variance X always plus. Even though it's minus, but then it will be always plus. Okay, this is variance Y. So that means now here it becomes variance L plus 2 variance S. So just now the variance L was 3 squared and the variance S was 2.5 squared. So when you calculate, this is going to be 21.5. Alright, So that means here I will write L minus 2S is normally distributed with mean 1, variance 21.5. And now you standardize it because this is normally distributed. So P Z more than 0 minus 1 over square root of 21.5. So this is going to be P Z more than negative 0.216. So now when we solve this question, right, I will just sketch a graph. Negative 0.216 is on the left side. And this is more than means bigger region. So this region is basically same as the bigger region after you reflect, because the negative value we can't get it from the table. The critical value is negative. That's why I flip it. I reflect it in the line y equals to the 0, okay, the symmetrical line. So this is your region now. That means this is same as PZ less than 0.216. And this property is available in the table. So you just read the table, and then you'll be getting 0.5855. And now you round up the answer to 3 significant figures. So this is going to be your solution. Okay, question 8. At a certain large school, it was found that the proportion of students not wearing correct uniform was 0.15. The school sent a letter to parents asking them to ensure that their children wear the correct uniform. The school now wishes to test whether the proportion not wearing correct uniform has been reduced. Okay. Now A. It is suggested that a random sample of students in grade 12 should be used for the test. Give a reason why this would not be an appropriate sample. Okay, because when you just consider grade 12 students, it cannot represent the whole school. You see, this is whole school, right? So that is the reason. So grade 12 students cannot be the represent of all students in the school. Okay, so this is a reason. It should be the random sample. Okay, now a suitable sample of 50 students is selected and the number of not wearing correct uniform is noted. This figure is used to carry out a test at 5% significant level. Right, state the suitable null and alternative hypothesis. Okay, so when you look at the question here, actually we are interested to check whether the proportion has been reduced. So you were given the proportion was 0.15 in the beginning. So our null hypothesis, which is the H naught, it will be P equals to 0.15. And you need to check whether it has been reduced. So P less than 0.15. That is our alternative hypothesis testing. Our alternative hypothesis. C. Use a binomial distribution to find the probability of type 1 error. You may justify your answer fully. Okay, so now type 1 error. Okay, basically I will just write binomial first. It is n is 50 and then the P is 0.15. So P type 1 error. Type 1 error is defined as H naught is true, but we reject H naught. Okay, so now it is alpha is 5%. So then from here, we always write reject H naught if P, now look at the H1 here, because it's less. So I will write X less equals to A is less than the alpha value. Alpha value is 5%. Right, so this is a definition. That's why now here, type 1 error means probability of rejecting H0 when H0 is true. So when H0 is true, this is your probability, 0.15. And now I need to count the probabilities so that the probability of X less equals to A is less than 0.05. Then that probability that we have found here will be the type 1 error probability. Okay, so now I will start with P X less equals to 1 first. I'm not sure what values should I take, but we need to consider at least one student. Okay, and now for your information, if it is binomial distributed with NP, the probability for this distribution is basically NCX, PX, QN minus X. Okay, and then the X start from 0, 1, 2, and so on. So now from here, I will write my X is binomial because I need to write down my P and Q. 50, 0.15. So that means P is 0.15. Then the Q is 1 minus 0.15. That is 0.85. Okay, so when less equals to 1 means that it will be 0 and 1. Because your X start from 0. So here it will be. Now, when X goes to 0 means that no success. The probability of success is 0.15. No success means all failures. So 0.85, and you are considering 50 students. Okay, plus, so 50 C1, 1 success, and then the rest are failures, 49. So from here, this is going to be 2.90545 times 10 power negative 3. Right? So this is a very small number. And then now I need to calculate the next value. So Px less equals to 2. Px less equals to 2 is basically Px less equals to 1 plus Px equals to 2. So I will calculate this value. I will just copy the answer from previous part. That's why I give more decimal places. Then I plus 50 C2. And this is going to be 0.0141885. And again, this is less than 0.05. So now we need to calculate the next value to check what is the probability, the highest probability. So that says X less equals to 3 means X less equals to 2 plus Px equals to 3. So I will copy this result. And then you will be getting 0.04605. Okay, so this one, it is close to 0.05. Now I check one more. So just copy that value and calculate Px equals to 4. Then you will be getting 0.1121. So this 0.1121 is greater than 0.05. So but then when you refer back to the definition over here, less equals to A, the probability of X less equals to A less than 0.05, then we reject H0. We need to reject H0 now. That means now my A is basically 3. Okay, because this is still less than 0.05. This is less than 0.05. But the 4 onwards, it will be greater than 0.05. That means now here, my P type 1 error, probability of type 1 error, it will be the probability of X less equals to 3. That is 0.04605. And now I round up to 3 significant figures. That is going to be 0.0461. So that is how we solve the probability of making type 1 error. Now D. In fact, 4 students out of 50 are not wearing correct uniform. State the conclusion of the test, explaining your answer. Okay, so now from the previous part, we know that when x less equals to 3, type 1 error. That means we reject H naught when x less equals to 3, the probability of x less equals to 3, which means the critical region is, okay, so critical region or rejection region is x less equals to 3, because when we count that probability, that is the probability of rejecting the H naught. Okay, so now when you look at the question here, given 4 students not wearing correct information, your x is number of students not wearing correct information. Now it is 4, but then when less equals to 3, we reject H naught. Okay, it's like this is a 3, less than 3, less equals to 3, at most 3, we reject H naught. Which means if it is greater than 3, we do not reject H naught. Okay, so from here we can find out the decision of your test, because you need to state the conclusion here. So you just write, since 4 is outside the rejection region, then do not reject H naught. This is a decision. So if decision is do not reject H naught, now the conclusion go back to the H1. So we do not reject H naught, right? That means we don't have enough evidence to conclude the H1, right? So the conclusion is insufficient evidence to conclude the H1. Insufficient evidence to conclude that the proportion has decreased. That the proportion of not wearing correct uniform has decreased. Okay, so that is our conclusion. Now E states with a reason which of the errors type 1 or type 2 may have been made. Okay, so now go back to the conclusion. The decision. The decision is do not reject H naught. Okay, so now your type 1 error, okay, just for information, type 1 error means P reject H naught. Given H naught is true. Okay, then P type 2 error, probability of making type 2 error, this is defined as probability of do not reject H naught. Given, sorry, the first one H naught is true. Given H naught is false. Okay, so now here, look at the decision from the test. So the decision is do not reject H naught. So when do not reject H naught, basically that is type 2 error. Right? So since the decision is do not reject H naught from part D. Therefore, or hence, type 2 error have been made. Okay, so that is the solution for part E. Alright, so I have completed the whole paper and also comes to the end of the video. Thanks for watching, and please subscribe to the channel and share this channel with your friends if you enjoy watching my videos. And also stay tuned for more upcoming videos. Thank you everyone. Bye.